Okay, these are atomic review questions. The answer key is at the back of the PDF, but I'm just going to go over all the questions. Make sure you have a calculator close at hand and also your reference table. Okay, which subatomic particles are located within the nucleus of a neon atom? And actually, you don't need to include neon because it's inside any atom. We have protons and neutrons. Those are what's inside the nucleus. Which statement best describes the nucleus of an aluminum atom? So let's go to the reference table. So here we have our periodic table, and I could go to the one pager, but I'll go to this one. So aluminum has 13 protons, and it's going to be 27 is how you round it. So 27 minus 13 is 14 neutrons. So let's see how that goes here. So the nucleus has, 13 protons and 14 neutrons. So which of those has charge? Not this. So plus 13. And what would be surrounding that nucleus? Well, if you have 13 positives, you'd need 13 negatives. So that would be choice 2. If it had a total of 10 electrons, that would be the aluminum ion, but this says atom, which is neutral. Which statement concerning elements is true. Different elements must have different numbers of isotopes. That's not true. You can have the same number. Different elements must have different numbers of neutrons. No, they can have same number. All atoms of a given element must have the same mass number. No, we've got isotopes. All atoms of a given element must have the same atomic number. That's right, because that's protons, which is identity. So it's choice 4. What are the characteristics of a neutron? So this is table O. It has no charge and no mass. I don't agree with that. It has no charge and it does have a mass. So that is our answer. So there's that. And let me just quickly show you back here. Way back here, table O. So neutron, the upper number is the mass, and this down here is the charge. So remember that. And also remember the beta particles are electrons. It's just a sneaky name for them. All right, back to here. Which subatomic particle has a mass of approximately 1 atomic mass unit each? So let's go back to this, 1 AMU each. So can't be alpha, can't be beta, can't be gamma, could be neutron, could be proton, can't be positron. So let's go back here. Neutron and positron, there they are. Nope, that's wrong. I just said that was right and it's not. Proton, electron, no. Proton and neutron, that's right. Pardon me. What are nucleons? Nucleons are what's in the nucleus. Again, what's in the nucleus? Protons and neutrons. As the number of neutrons in an atom increases, nuclear charge. Well, remember, neutrons are neutral, so you're just getting heavier. You're not getting any different in charge, so it would be remaining the same. What conclusion was a direct result of the gold foil experiment? An atom is mostly empty space with a dense, positively charged nucleus. Boom, that's it. And that's because you had that thin gold foil. Most of the alpha particle beams went straight through. Some came off at weird angles, and very few came back. So that's because most of it's empty, except for that small positive nucleus. Which sequence represents the correct order of historical developments? So first we had Democritus. By the way, there's a whole timeline in your notes, starting with the hard sphere, atomos, kind of like the billiard ball or a lacrosse ball. Then we have most of the atom is empty space. That's Rutherford. Then we have electrons exist in orbitals, which is Schrodinger. That's right. Orbitals came after because we had to first figure out electrons were outside that nucleus and all that space. Compared to the entire atom, the nucleus is smaller, very small, and contains most of the mass. Because remember, electrons are basically 0, but they do have a little bit of mass, so that's why it's not all the mass, it's most of the mass. What is the total charge of a nucleus of a nitrogen atom. So let's go back to reference materials. We got to go to the big one because that one is sideways. Sorry about this. Where are we? Here we go. Nitrogen. So looks like we've got atomic mass of 14, 7 protons, so that means 7 neutrons also. So let's go back to here. In the nucleus, we have 7 protons, we have 7 neutrons, and then we only care about positives, so this is plus 7. What is the net or overall charge of an ion that has 9 protons, 10 neutrons, and 11 neutrons and 10 electrons? So we don't care about those because this is about charge. So if we have 9 positives and 10 negatives, we're going to be overall minus 1. An atom is electrically neutral because number of protons, positive, equal number of electrons, negative. Choice 1. Which symbol represents a particle with 10 electrons? So the first thing we need to do is we could say this has 7 protons. This has 7 protons. I remember from my other, this has 13 protons, and this is 13 protons. That's a 13. Now, since there's no charge written here, see how that's just neutral? You'd have to have 7 electrons, so that's not our answer. This would normally have 7 electrons, but if it's minus 3, it means we've lost 3, so this would be 4 electrons. That's not it. Aluminum, if there's no charge, would be to have 13, and that would mean we lost 3. So that's why it's choice 4. Which statement is true about the charges assigned to an electron and a proton? Both are positive? No. Electron is positive? No. Electron is negative, proton is positive. These are just definitions. Isotopes must have the same atomic number, but different mass. So we need the same number on the bottom, because that's atomic number. Oh, and look, that takes care of it right there. So you see we have a different mass, 1 here and 3 here, but the same number of protons. Which notation represents an atom of sodium with an atomic number of 11 and a mass number of 24? So the mass number always goes up top, and the atomic number goes on bottom, symbol here. So choice 1. What is the mass number of an atom that has 6 protons, 6 electrons, and 8 neutrons? So electrons basically have no mass, so they're gone. So 6 plus 8 is 14. In which list are elements arranged in order of increasing atomic mass? I would have to look. So let's go back. CLKAR. CL 35.4. AR is 39.9. Where's K? 39.09. Yeah, that looks like that's it. Guys, I really don't want to waste time on that. I believe it's choice 1, but I'm going to say check this because I can't go back and forth over and over. I don't have my periodic table right next to me. The number of neutrons in the nucleus can be determined by, okay, so it's mass number minus protons. So subtracting atomic number from mass number. There we go. Which has the smallest mass? Electron, which is 1 over 1836, or essentially 0. The mass of electron is approximately 1 over 1836, the mass of, this has no mass, this is a mass of 4, this has no mass, this is a mass of 1. So that's our choice. Isotopes are atoms that have the same number of protons but different masses, and that's not a choice. So if you would have the same protons but a different mass, that means we have different neutrons. All isotopes must have the same atomic number because they're the same element. Okay, so we have 3 isotopes. They have the same number of protons but different number of neutrons. Yes, because our mass is different. Electrons basically have no mass. The nucleus of an atom of K42. So 42K, and I think is it 19? Notice that I don't even know 19 because I can just look it up. Okay, so 19 protons and 23 neutrons. Choice 1. What is the total number of neutrons? Okay, so we subtract. So 19 minus 39 minus 19 is 20. Which value of an element is calculated by using both the mass and relative abundance? Okay, so this is mass, atomic mass, because you do the mass and relative abundance. It's a weighted average. Which statement best explains why most atomic masses are decimals? Because they are the weighted average. We take into account the relative abundances and only the naturally occurring, not artificially produced, because we're not sure of their masses if they're artificially produced. We're sure of their masses if they are naturally occurring. Element X has 2 isotopes. If 72% of element has isotopic mass 84.9, blah, blah, blah. Okay, so we're going to do mass times percent abundance and mass times percent abundance over 100. So we would need to, so it can't be 1 because they're not dividing by 100, and there's subtraction going on in 2. And again, there's no dividing by 100, so it has to be choice 3. The other option would be 72.0 times, make this into a decimal, and then this would be 87.0 times 0.28. You can do that because I'm not dividing by 100, but you couldn't subtract or any of that junk. How many electrons are in the outermost principal energy level or shell of an atom and carbon in the ground state? So 2-4, that's the electron configuration. You can use your periodic table. And it says how many are in the outermost. So that would be 4. In a calcium atom in the ground state, the electrons that possess the least amount of energy are, okay, so remember we're at the concert. Where do you have to sit at the concert so that you're just getting the best view and you're not stressed out and you're not straining? Right in the front. So first, which principal energy level can hold a maximum of 18 electrons? So remember the Bohr formula is 2n squared. So if I have 5, that would be 25 times 2 is 50, so it can't be that. That would be 2 times 2 is 4, times 2 is 8, or 2 squared. 3 squared is 9, times 2 is 18, so that's my answer. According to the wave mechanical model, electrons in an atom are located in orbitals. This is a definition. So if you were confused, check it out. It's a definition. Okay, so we've already talked about this, I believe. What comes first is hard sphere, then we have electron shell, then we have wave mechanical. So this is like a Democritus, followed by Bohr, followed by Schrödinger. I think there's a C there. Now, the next few are going to be honors only. So if you're in the college prep, you can come back to me when we are in, I believe, 43. So these are honors only. Which orbital notation represents a boron atom in the ground state? So boron has 5 electrons. So how do we fill? No, we can't do choice 1 because you got to double up the 1s first. 1s, 2s. This looks good, so I'm going to say potentially that. No, it can't be 3 because we totally skipped that. And nope, can't be 4 because we didn't fill that. And we know it's the ground state, so it has to fill normally. So it's choice 2. In which group of elements do most atoms have completely filled S and P valence sublevels? Now, valence means outermost. So if you are completely filling the P is all the way to the right of the periodic table. So that would be the noble gases, all the way to the right. Which of the following sublevels has the highest energy? So which is the highest out? 1s, 2s, 2p, 3s, 3p. So the 3p is the highest because it's the furthest away. Which electron configuration represents an atom of lithium in the excited state? So remember, so we should first figure out what lithium is normally, which is 3 electrons, 1s2, 2s1. So that would be choice 3. Can't be that because that's the ground state. So we need to have a total of 3 electrons just shifted. So since I'm right here, can't be choice 4 because there's 4 electrons. And it can't be choice 1 because it's only 2 electrons. So the reason why it's choice 2 is because we've shifted 1 from the first S. I don't know how that happened. Over to the second. So that's not filling in the traditional way. Which of the following elements in period 2 has all of its sublevels completely filled? If we were looking for completely filled, those are noble gases. Choice 4. Which electron transitions represent the release of energy? That would be moving down. So this is moving up, this is moving up, this is moving down, this is moving up. So again, you gain energy, you jump higher. If you lose energy, give it off, you come lower. Which particle contains the greatest number of electrons? So if I'm looking on periodic table, neutral sodium, 11 protons, which means 11 electrons. This would have 11 protons, but we've lost 1, so 10 electrons. Fluorine neutral is 9 protons, 9 electrons. And that's a minus sign, so that means you've gained 1. So the greatest number of electrons would be choice 1. Okay, now everybody can jump back in the college prep and the Regents. College prep and the honors. Okay, so we've got some spectral patterns. It says identify the 2 gases in the unknown mixture. So I just travel up. So do. So it looks like we have gas A and we have gas D. Explain the production of an emission spectrum in terms of energy states. So if you don't talk about energy states, you're wrong. So you can say spectra are produced as electrons give off energy. If you were to stop there, it's wrong because we didn't talk about the states. So I must continue and travel from higher energy states to lower. Now I'm correct because I talked about the energy states. One model of the atom states that atoms are tiny particles composed of a uniform mixture of positive and negative charges. Scientists conducted an experiment when alpha particles were aimed at a thin layer of gold atoms. Most of the alpha particles passed directly through the gold atoms. A few alpha particles were deflected from their straight line paths. An illustration of the experiment is shown below. I just gotta say, if you don't read the writing here, like if you just skip that, you might miss something. So always read it. 45. How should the original model be revised based on the results of this experiment? Well, the original experiment said it was uniformly mixed of positive and negatives. But I now know that there is a positive center. So you can say we have a positive center or positive core with electrons on the exterior, something like that. And it's also mostly empty space. That's actually the answer for 46. Why did most of them pass through undisturbed? It's because an atom is mostly empty space. A few of the alpha particles were deflected. What does this suggest about the structure of the gold atoms? There is a small, dense, positive, centrally located region called the nucleus. And that's why they were deflected. Okay, base your answer to the following question on the electron configuration, which is the excited state of a calcium atom. So let's go back to this. Let's go to calcium. Calcium has 20 electrons now. They're using the Bohr configuration, so I suppose we should go to the other one. So, sorry, it's crooked. 2882 is the ground state. So this is ground. So that would mean you have 10 and 20 electrons total. So we cannot use X. Y. Y is the answer because look, one of these has jumped up to here. So this is excited. Calcium. Ground calcium. 288. That's not calcium. That is 18, which is argon. It's a different element altogether. So element Y. John Dalton was an English scientist who proposed that atoms were hard, indivisible spheres. In the modern model, the atom is different internal structure. Identify one experiment that led scientists to develop the modern model of the atom. You could say the cathode ray tube experiment. That was J.J. Thomson. He's the one who discovered the electron. He had the plum pudding model. Or the classic would be the gold foil experiment by Rutherford. So if I did choose the cathode ray tube experiment, you would describe it by saying Thomson electrocuted gases throughout a glass tube. He noticed a gleaming beam of particles were moving towards a positive plate, which indicated something small and negative within all gases, and so that's the electron. Or the gold foil experiment, which everybody knows, talking about how most of the alpha particles went straight through, meaning an atom is mostly empty space, a few deflected, and very few bounced back, which means there's a small, centrally located positive nucleus. And we were talking about the conclusions of the structure. Finally, average atomic mass. Showing a correct numerical setup, that means you don't solve. Correct numerical setup means you just plug it in. But then it says to solve. And then, sig figs. So, you do your mass. That is messy, I apologize. Times percent abundance. Plus mass. And by the way, this formula is not in the reference table. So you have to either write it down or just know it, I guess. So let me pull out my calculator. 10.01 times 19.91. That's 199.2991. And then I'm going to multiply that by 11.0. And I haven't rounded to sig figs yet, so don't worry. 881. Okay, so 199.2991 plus 881 plus 0.7909 is 1. Then you gotta divide by 100. You get 10.8109. However, looks like we've got 4, 4, 4, 4. So don't worry about the divided by 100. So 4 sig figs would be 10.81. And again, units would be AMU. I would also accept EU. Okay, that's it. By the way, all your answers would be here. So we just went through them. If you continue to have questions, please let me know. Otherwise, thanks for watching.